Okay, so this is still about using identities to integrate trigo functions. So this is a specific case lah. It's specified in the syllabus as one of the cases you need to know as a product of sine, cosine, sine and cosine, like sine sine, cosine sine, or cosine cosine. A product we cannot integrate directly. So for example, cosine 2x, sine 2x, or okay, something else, sine 4x, for example. Okay, we cannot integrate this directly. We haven't learned anything yet that fit this form. But we can use this factor formula, which is found in MF26, to convert from the right hand side to the left hand side. You can see that it changes a product to a sum. So we know how to integrate sine something. Alright, so and also cosine. So these are trigo identities, trigo functions we can integrate. So that's the whole purpose lah. So whenever you see a product of sine cosine, we are able to use the factor formula. So let's see how we can use it here. Okay, the trickier thing is that this formula is useful to change from left hand side to right hand side. But unfortunately, most of the time, we actually require the reverse. So that takes a bit more work lah. So that's what you should be looking out for in this section. Okay, how do we compensate for that? One way, if you remember, one way for you to remember is, if you can remember this, you can call this A, you call this B, and then you realize that actually how do we get P, right? It's just take A plus B, and then we can take Q to be A minus B. Because if you just take P plus Q over 2 plus P minus Q over 2, you will basically get P. And you take A minus B, you get that. So that is how we can change. So later I will go through that example, if you can remember that. Okay, so let's look at a way to do it without, if let's say you can't remember what I just said, how do you work it out? Okay, so let's look at this one. Oops. Okay, so this is a product of sine and cosine. So we're going to look at one of the formula to change from sine cosine to sine sine. Okay, I'm going to put it down here. So this is what we're looking at. Sine plus sine, sine cosine, we want to change it to this one. Okay, so if you look at the formula here, we're trying to let this be our P plus Q over 2 and X to be our P minus Q over 2. Okay, so we're going to write it down here. P plus Q over 2 will be 3x, and P minus Q over 2 will be our x. Okay, so you can solve this perhaps by adding the two together lah. So it's like something simultaneous. If you take equation 1 and equation 2, for example, if you add them up, you will get rid of the q already. So you get p equals to 4x, for example. Okay, so similarly, you can get, if you take 1 minus 2, you will get q equals to 2x. Okay, so in this case, I can then change basically 2 sine 3x cos x will give us sine p, which is 4x, plus sine q, which is 2x. Okay, so from here, these are standard forms. Again, you need a 4 here, so in the end, we have to divide by 4 to compensate. Okay, if it is too fast, you might want to recap the previous section. Same here, cosine 2x divided by 2, and that's the answer. Okay, alright. So if you can, so this is what, if you just look at MF26, that's what you can deduce your P and Q. But if you recall, if you remember that this is actually A, this is actually B, then this would be a plus b and a minus b. For instance, you can straight away get p by taking 3x plus x. That's 4x. And then to get b, you can really take a minus b, which is 3x minus x, okay, which is 2x. So this is much faster if you can remember lah. If you can remember to let your p plus q over 2 be a and p minus q over 2 be b, then your p and q will be a plus b and a minus b respectively. Alright? Alright, so let's look at some other examples. Okay, so again, once you see a product of sine and cosine, or now in this case just sine, I think I copied the wrong formula. Okay, sorry, let me erase this. Okay, what we want is really not this one. Okay, what we want is to convert sine, so that gives us cos. This is what we got from earlier, if you just refer. Minus 2 sine p plus q over 2 sine p minus q over 2. So this is the formula you want to refer to. Okay, so we want to change this to cos minus cos. So again, we're going to let this be p plus q over 2, p minus q over 2. So I'm just going to do it quickly. P plus q is 4x, p minus q over 2 is 2x. So if you add the two together, you get p. So you solve this simultaneously, you get p equals to 6x and q equals to 2x. Okay, therefore we can get this form. Okay, then is cosine minus cosine is a straightforward integration from the previous section. Okay, so it's quite similar. Okay, next, okay, I think this is still required. Oops, okay, never mind, you can still see. So I will not focus so much on the finding of p and q. I hope kind of know how to do. So again, if I want to go back to the previous method that I was talking about, I always let this be a, let this be b, and I know that this will be a plus b, and this will be a minus b. Okay, so in this case, I can directly change it to, okay, there's a half here. Okay, remember this one, there's 2. So from here I can get, there's cos, okay, I'm just going to rewrite this. Cos A cos B equals to half of cos A plus B plus cos A minus B. Okay, so I'm going to apply this. So to get half of cos 5x plus cos x, okay, because a minus b, so we get half of cos 5x plus cos x. Okay, so integrating cos x will give us sine 5x over 5, and this will give us sine x directly. Okay, so that's the answer. Okay, so I've shown you two slightly different methods lah. You can also, of course, equate your p and q again, like we have mentioned, p equals to 3. Sorry, p plus q, I mean. Okay, so comparing with the formula, you want to let your p plus q over 2 equals to your 3x, and your p minus q over 2 equals to your 2x, and then try to solve for p and q. So that's the other method. Okay, so okay, last one. Okay, we will not, or rather we are done. Just to show you one example where things can go a little bit wrong. So if you compare the two, okay, this is what we've done already. Okay, cos 3x, cos 2x. Okay, we've done it in the earlier example. What if you, instead of giving cos 3x, you give it this? Okay, this is obviously the same as this because it's a matter of a times b versus b times a, which is the same thing, right? So, but if you just take this to be the first thing you see to be p plus q over 2, then you realize that you will get negative answer for q, which is fine. But generally you don't like negative answers because it complicates things. So for example, if I get to here, you realize a cosine negative x, but you need to realize that cosine negative x is actually cosine x. This is a property. We'll go through this now. For example, you might get sine negative x, and then there's negative sine x. So you can still compensate for it, but it makes things a little bit trickier. So I prefer not to. So if I'm given this, I will always rearrange just to change it to the bigger one first, so that I will avoid having a negative answer for my P or Q. So this is just a tip lah. If you forget, you can still get the answer lah. Don't panic if you get a negative answer. Just remember that you can always relate negative angle, cosine or negative angle back to the one without. So cosine negative x, for example, is cosine x. Cosine sine negative x would be sine x. Oh, sorry, sine negative x is negative sine x. Okay.